AP AP Calculus BC, Unit 6, Day 6 office hours, solving differential equations and specifying the domain, which is a given on this problem. So it's a quick little rundown how to solve differential equations and then some comments about domain. If f is continuous, the initial condition pins down the solution on its entire domain. If f of x is discontinuous or non-differentiable, the initial condition pins down the solution on the continuous and differentiable portion of y equals f of x that passes through the initial point. Single open interval. So these are the answers in case you haven't checked them. This is 1, 2, and 3. You need to specify the domain. Pause the video if you need to check those off. You can write them in interval notation if you like. That's fine. And this is the back. 4, 5, 6, 7. Pause the video if you need to. Check your answers. Okay, so let's try these out. A bunch of these on your next test. Okay, so you have to separate the variables, which this time is pretty easy because everything on the right side is already x. There are no y's, but you can still separate the variables. So integrate both sides. Y equals 2x squared over 2. Antiderivative secant is tangent plus c. Use the initial condition. Tangent 0, 0. C equals 3. Rewrite it. Y equals x squared minus tangent x plus 3. So that part is pretty easy. Now the domain, tangent has its own issues, right? Tangent, when does tangent x equal undefined? Because those are discontinuities. So that would be sine over cosine. So that'd be when cosine equals 0, you get division by 0. So that's going to be when x equals pi over 2 plus pi k. So there's that issue. You also need to worry about secant in the derivative. So secant could equal undefined. And that would be 1 over cosine equals undefined. So that'd be when cosine equals 0, which is the same thing we just found. And a lot of times that happens, not all the time. So, I mean, I would do, just to help make it easier, I do a little line check, pi over 2, 3 pi over 2, you know, and there's infinite places. We want 0. We want the chunk with the 0 on it. So your answer is y equals x squared minus tangent x plus 3 for the domain, negative pi over 2 to positive pi over 2. That's your answer all together. Okay, initial condition is what identifies which of these. This function on its own is all of these open intervals, lots of them. But as a solution to a differential equation, you can only do one open interval. Okay, so here, this one is pretty easy as far as separating the variables. We integrate both sides. X squared over 2. This is x to the negative 2. So it's going to be x to the negative 1 divided by negative 1 plus c. We could write a little nicer maybe. Plus 1 over x. Initial condition, plug 1 in for y, negative 1 in for x. So that's going to be negative 1. We're going to add to the other side. It's going to be 2 minus 1/2. So c equals 1 1/2 3 halves. So we rewrite it. Y equals x squared over 2 plus 1 over x plus 3 halves. But there's an issue here. X cannot equal 0. We also should check up here where we happen to have the same issue. It's pretty common. Always double check. Something could come up here that didn't come up here. So to me, I'll just put open dot at 0 and pick the chunk that has the initial condition on it. Now I just put a little solid dot. In no way should that be part of your domain. I'm just gonna don't break it up there or whatever. That's just identifying which one. So the answer is y equals x squared over 2 plus 1 over x plus 3 halves for the domain negative infinity to 0. That's how you do it. Okay, let's do another one. Okay, this one actually does involve some actual separation of variables. Integrate both sides. Natural log the absolute value of y plus 1 equals natural log the absolute value of x plus c. Plug 1 in for y. And we plug negative 1 in for x. Natural log of positive 1 is 0. So c equals natural log of 2. So we're going to rewrite it. Natural log of y plus 1 equals natural log of x plus natural log of 2. So we could use log rules here. Combine this as 2 times the absolute value of x, right? Or you could do that later. You can exponentiate both sides. If you didn't combine them, you could have said, oh, this is going to be e to the natural log of the absolute value of x times e to the natural log of 2, and that would have given you 2. And that would give you absolute value of x. So then to get rid of the absolute values on the left, it's going to be plus or minus 2 absolute value of x. And we should choose if it's positive or negative. When you plug in negative 1, it's going to give you positive. That's going to give you 2. When you plug in 1 over here, it should give you 2. It needs to be the positive one. So y equals 2 absolute value of x minus 1. Now, I'm telling you, anytime you have absolute values in the answer of the solution of the differential equation, you're for sure going to write your final answer without them, because I guarantee there's a corner there that you're going to have to break up your domain at. So this is defined for all reals. The domain of this, no issues, none at all. But there's a sharp corner there where the derivative is undefined. So that's not good. So we got to break it up. So we're going to do, I would just open dot at 0, the initial conditions at negative 1. So this is going to be our domain. Okay. As a picture, what this looks like just visually is it's a V graph that's been shifted down 1. It has a slope of 2. So it looks like this. If they asked you to sketch it, though, you would say, oh, we're just going to do open dot here. And the left side, it's got to stop at that. Okay. Now, because we know it's going to be negative, we can rewrite it as y equals 2 and drop the absolute values and put a negative in there to force it to become positive like the absolute value would. So your final answer is going to be y equals negative 2x minus 1 for the domain negative infinity to 0. There you go. Okay, number 4, separate the variables. I'm going to change to y to the 1/2. We're going to integrate both sides. Y to 3 halves, divide by the new exponent, equals 2x plus c. Plug in the 9 for the y, plug in 0 for x. So c equals square root of 9 is 3, cubed is 27, divided by 3 is 9, times 2 is 18. It's going to be 2/3, y 3/2 plus 2x plus 18. Now we just got to solve it. So multiply both sides by 3/2. And we will get 3x plus 27. And then I'm going to raise both sides to the 2/3 power to get rid of the 3/2 power. So y equals 3x plus 27 to the 2/3. Now, are there any issues with this? No, because it's a cube root. When we take roots, positive, negatives, no issues there. But, so I mean, the domain of this is all reals. Okay, but that's not good enough. Gotta look up here. Y cannot equal 0. Now, don't put 0 on your number line. That's a y value. We need x values. So we're gonna say, well, what's the x that causes that? Well, let's take our new equation for y in terms of x and set it equal to 0. Figure out when that happens. So we're gonna raise both sides to 3/2. And subtract 27 both sides and divide by 3. So x cannot equal -9. When x equals -9, y equals 0. That's what we can put in our number line, -9. The initial condition is right here is 0. That's your domain picture of it. So your final answer is 3x plus 27 to 2/3 for the domain -9, positive infinity. Got to give the domain. All right. Number 5, separate the variables. Integrate both sides. It's a power rule. Bump it up 1, divide by the new exponent. Use initial value. So that's going to be -3 cubed is -27 over 3 is -9. So c equals -6. So y minus 3 cubed over 3 equals x minus 6. Multiply both sides by 3. I'm going to take the cube root of both sides. And then I'm going to add 1. Now, this on its own, domain, all reals. No issues. But y cannot equal 1 because the derivative is not defined. We got to find the x that makes y equal to 1. So we do a little more algebra. Set our y equals in terms of x equal to 1. Subtract 1, subtract 1. Cube both sides. Add 18. Divide by 3. Do a line check. Open dot at 6. Initial condition is at -3. That's your domain. So our answer is y equals cube root of 3x plus 18 minus 18 for the domain -infinity to 6. Next one. Separate the variables. Integrate both sides. We're running into an issue here. We can't integrate this. We have to use partial fractions. Hey, you guys are friends, right? So that's going to equal a over y plus b over 1 plus y dy. So all of our heavy side is approach. By the way, this might look close to logistic, but logistic is ky m minus y. So this plus makes it not logistic. Sorry, even if it was logistic, on your next test, I'm expecting you to do it by hand. There will be some logistic problems where you can use shortcuts, but then there's going to be a differential equation where you just got to do it out. And it's going to be pretty much the work we're doing right now. So we multiply through by least common denominator. We, eliminate one of them. A equals 1. We eliminate the other one. B equals -1. So we're going to get 1 over y minus 1 over 1 plus y dy integral of dx. So I think we're ready to integrate. We're going to get natural log of the absolute value of y minus natural log of the absolute value of 1 plus y equals x plus c. I'm going to use the log rules right now to combine these together. Use the initial condition, plug in -2 for y, 0 for x, c equals natural log of 2. You rewrite it, natural log, y over 1 plus y equals x plus natural log of 2. Now exponentiate both sides. Use rules of exponents to simplify this. Get rid of the absolute values, plus or minus. Now let's choose if plus or minus right now. If you plug -2 over -1 is +2. We want the positive. Then we got to solve for y, so we're going to multiply both sides by 1 plus y. So we get 2e to the x plus 2e to the x y. We're going to bring our y's on the same side. Factor the y out. Divide both sides by the coefficient. And there's our answer. Okay, domain, no issues in the derivative. Nice. This can't be 0. 1 minus 2e to the x cannot equal 0. So let's solve for that. 2e to the x cannot equal 1. Divide by 2. Take the natural log of both sides. X cannot be natural log 1/2. So we'll do a quick line check. Now here's the big question. Is that positive or negative? Think about the natural log graph. This is 1, 0. So 1/2 is negative, which means that x equals 0 is definitely to the right of it. So your answer is y equals 2e to the x over 1 minus 2e to the x for the domain natural log of 1/2 to positive infinity. That's it. Now, you could also write this as negative natural log of 2 if you want. Whatever. Same thing. Okay. Got to put the domain. All right. Last one. Now, to separate these variables, we got to factor the y out first, because you can only use multiplication and division to separate the y's and the dy. So this is going to be y dy equals 1 over x plus 2 dx. Integrate both sides. Y squared of 2 equals natural log of the absolute value of x plus 2 plus c. Use the initial condition. -4 squared over 2 equals natural log of -1 plus 2. This is going to be natural log of 1, which is 0. So c equals 8. So y squared over 2 equals natural log of the absolute value of x plus 2 plus 8. Multiply both sides by 2. Take the square root of both sides, plus or minus. So that's our answer. I know we're going to be able to get, well, we got to decide is plus or minus. When you plug in -1, you get natural log of 1 is 0, square root of 16 is 4. It's supposed to be negative, so you actually want the negative. I know for sure we're going to be able to get rid of the absolute value on the inside, but there's also there's a couple issues here. So, one, if you go up here, x cannot equal -2 and y cannot equal 0. So those are two issues. The inside of this has to be positive or equal to 0. So we could solve for that. Essentially, we don't need to worry. We don't really need to even keep track of the inequality because we're not going to do any tests or anything like that. So we can just say, well, it can equal 0. Now, by the way, that's the same thing as y not equaling 0. We're setting this equal to 0. So that's going to take care of that. But there was a new thing right here. So natural log of the absolute value of x plus 2 is going to be -16 over 2. Exponentiate both sides. X plus 2 equals plus or minus e to the -8. And we need both of those. So x cannot equal -2 plus 1 over e to the 8th and -2 minus 1 over e to the 8th. So we got a bunch of issues here. So our number line, we got to figure out what these are. -2, this is a little bigger than -2, right? Just add a little something. This is a little smaller than -2, so it should be to the left of it. You subtract a little more. The initial condition is -1, so where does that lie? Well, let's see. I mean, e to the 8th, this is really close to -2. It's probably like -1.9 or something. So -1, I'm pretty confident is over here. That's going to be our domain. These should all be on here. So your final answer is y equals negative square root. Now, because I know I'm going to be plugging numbers in that are bigger than -2, right? Then we know that this is always going to be positive because we're going to plug numbers that are bigger than -2 in, right? So that's always going to be positive. So we can just drop the absolute values. We should. Okay, so that's 1 for the domain. -2 plus 1 over e to the 8th, comma, positive infinity. That's the answer. So this domain stuff, some people just don't even do the domain. That's going to be bad. A lot of people just look at this for domain issues, but then there's this other issues for the derivative, and it's just a single open interval. Some of you guys can give me multiple intervals. It's not even a thing on these problems. So that's it.